For lecture 8, we're going to be talking about gradient vectors. So let's talk about what the gradient is. The gradient is something that happens when we have a function as opposed to a parameterized curve. This is the opposite. Instead of a function with one input and many outputs, this is a function with one output and many inputs. So that's a real valued function. And in that case, the derivative matrix, df, is going to just be a row vector. That row vector is going to change as we go from point to point to point across space, and we call that vector the gradient. So in this kind of situation, like before, we usually think of the function of several inputs as measuring something that's happening at various different points inside space. So at each point we might have a temperature, and the gradient is going to tell us something about temperature. It certainly tells us about rates of change of temperature already. And the gradient has a couple of geometric properties. It has two main ones. Because it's a vector, even though it's a row vector, it has magnitude, how long it is, and it has a direction. It points in a particular place. And the direction of the gradient is going to tell us something very specific. The direction of the gradient tells us what direction the function is increasing the fastest. Whereas in the opposite direction, that points away from it, it tells us where it's decreasing the fastest. So, for example, if we think of the function f as measuring temperature, and we're cold and we want to heat up, what we should do is we should take the gradient at our particular position in space, and that'll point us in the direction where we should go if we want to heat up. If instead we want to cool down, we should go in the direction opposite to the gradient. Whereas if we're just fine and we just want to go for a walk, then we just go in some direction that's perpendicular to the gradient, because in those directions the function really isn't changing. And if we continue to do that, if we continue to follow the gradient, we'll increase as fast as possible.